Hi, this is Matt Ratliff from the Autodesk Alias product support team, and this video is on aerospace nose modeling. As a video overview, this video will discuss and review several workflows for modeling an aircraft nose in the Alias 2010 product. So to start off section 1, we'll demonstrate a method for building the nose out of a primitive cylinder in Alias. This technique is a sculptural approach to modeling, similar to what a clay sculptor would use. So we'll be pushing and pulling CVs to achieve the desired shape. The CVs will then contain an optimal structure. It allows a quick communication of form. And for polygonal modelers, it's similar to polygonal box modeling in the sense that we'll be taking a shape and actually extruding it in a sense to rough out the shape that we're looking for. Okay, so to get started, we have a 3rd degree 8-span cylinder that's placed in here in the viewport, and we also have a reference canvas image of an aircraft. So what we're going to show is just a quick direct modeling push-pull technique, similar to what a clay sculptor would use to achieve desired form. So we're going to go in here in our front view, and on the face of the cylinder, we're just going to go ahead and pick CVs, and just make sure that you get them all picked. And then we're going to go and we're going to scale them out so they line up with that hull, or those CVs I should say. We're going to do the same thing on the inside of this face, and we'll stop maybe right there. So if I shade it real quick, you're going to see that we've already achieved a really quick nose shape here with a pretty good hull structure and CV structure. So now we'll switch to a side view, and I'm just going to turn patch precision on the surface there so I can see the shape, and we'll also just move it in kind of a quick position in reference to the image. Now we're not going to show getting this exactly lined up to the reference image, but we'll get it pretty close. So just pick these CVs, bring these up so they line up on the bottom, and we'll kind of do the same on the top. I'm just going to add a span in here so I can add a little more detail. And I'll go ahead and pick this CV and bring this down. So you can see that really quick we've got a pretty good form going on this aircraft. And in the next section, we'll just give it a quick evaluation, and we'll talk about some of the disadvantages of using this technique. So with the quick nose shape roughed in using this method, just giving it a quick zebra stripe, you can see that the highlights look pretty good for the method here. And we also saw earlier that the CV and hull structure looks pretty good as well. So what we're going to do now is we're just going to show a quick just a quick curvature comb on here. So we'll isolate this front surface here. And what I'm going to do is just go ahead and put on my curvature comb here. And we'll just make it a little smoother. And what you can see is there's some interior breaks in here. So that's actually one of the main disadvantages of using this technique, is you can see that it's not completely smooth. So for conceptual work this might be fine, but if it's for downstream use, or you want to actually use this as a technical type of surface, this methodology is not really going to work for you. So to summarize this technique, the push-pull technique is more of an organic surfacing approach to design modeling. It's similar to what a clay sculptor would use in actually blocking in a model or roughing in a model. The CV structure is pretty organized in this technique, but after evaluation of the surfaces, you'll notice that there's curvature breaks along the surface shape. So this method is not entirely accurate or precise enough for technical surfacing type of work. So in section 2, we'll be utilizing a typical designer approach to modeling the nose. Many times in the industry, designers focus heavily upon clean curve networks or upon building curves. So this will be a great method for surface building after a curve network is already completed. It's also great for on-the-spot designer requested surfaces. If a designer is working with you on a curve network and wants to see what that would look like in surfaces, it can be done very quickly. Okay, to get started here in section 2, what we have is a primitive cylinder body similar to what we had in the previous section, but we also have some curves that were drawn in. So this would be similar to what a designer would come and either draw for you or work with you to draw. So this is just a kind of a simple curve network here, and it all meets at the center point of where the nose comes together. So this is what the designer wants for the shape of the nose. So what you can do is you can actually utilize the curve network tool to actually build a quick curve network in here, and this is great for an on-the-spot surface request or something like that. If you want to come up with a quick surface to show a designer, if you want to just see maybe what a surface would look like with a certain curve network. So if you haven't utilized it before, if you go into your surfaces in your palette, curve networks, this will bring up this curve network tools toolbox here. So we're just going to click on new curve network, and we're just going to select all of our curves. So I'm just selecting all these boundaries here, and we're just going to go ahead now and hit go. So this is just going to create a really quick surface network. Then we're going to click the tangent continuity here to get tangent continuity. So after this is completed now, you can make obvious design changes in here if you want to move some of these out, move things up or down. The history will update on these surfaces. So again, this is great for a quick surface request or during the early conceptual stages. So to summarize the second workflow, this method is great for quick conceptual surfacing or early shape definition. Some disadvantages to keep in mind is that you really can't achieve good highlights in surface flow using the default curve network tool palette. You're also limited to tangent G1 continuity rather than being able to achieve curvature continuity or even higher G3 continuity. In section 3, we'll utilize a more traditional technical surfacing approach. Many of these surfaces are typically modeled from scan data and as four-sided patches. This will allow the surfaces to then function as suitable downstream surfaces. So in this section, we're going to utilize a more technical surfacing type of approach. So what we have is we have a polygonal mesh of the airplane shape that we're looking for, or the nose shape that we're looking for, I should say. And we have some surfaces that are snapped onto the mesh. So we're going to go ahead and just hide those. We want to build this boundary right here for the front part of our nose, but notice that it's a three-sided boundary. So to make it a four-sided boundary, we're going to just go ahead and switch to our side view, and I've created some quick curves here to project onto this surface. So we're essentially going to trim out this area and use this as our surface boundary. So we're just going to come in here with the square tool, and we're just going to build a quick square boundary in here. And I like to use cubic a lot of times on the square tool because you can do some real good CV manipulation without having to do a lot of direct modeling just by sliding this manipulator. So notice how as I slide this manipulator, you can see that the CVs interactively move as I slide that. So now what we're going to do is just go ahead and shade up our model, and we're just going to come in real quick with the align tool and just try to get some quick continuity here. Okay, so now we've got our tangency here that we want, and we're going to come in and we're going to do the same thing in this area, and just going to add another span in there. Okay. So what we're going to do now is, if you notice, if we go ahead and just apply this on a layer, you'll notice that there's probably a curvature break here in the center, and there is. So what I'm going to do is actually just going to turn symmetry off, and we're just going to go ahead and turn our grid on, and I'm just going to go ahead and set my pivot at the origin, and we're just going to use the duplicate object tool. I've set it for -1 on the Y, and we're just going to flip that over. So now what we're going to do is go ahead and turn our surface continuity back on, and I'm just going to use the old align tool with continuity of curvature set as well as both, and we're just going to align them both curvature here. Okay, go ahead and turn my grid back off. And notice now that we have a pretty good approach here, or a pretty good surface. And I'm just going to go ahead and dupe that over real quick. So now we have a pretty good surface modeled in here. And I've done a little bit more manipulation on this layer here. So we have a final set of surfaces here that I'm going to go ahead and show. And we'll just turn some of this transparency off. And you can see how quick and easy we can use a lot of the tools to achieve a nice technical surface type of shape. So to summarize this technical surfacing method, it's a great method to use when a high surface fidelity is typically required. You can achieve very good highlight and CV flow using this method, and there's not really any limits on continuity or shape. You can also utilize a lot of the direct modeling methods to interactively sculpt, such as what we've shown in previous examples. But in this approach, you'll get a lot better highlight flow, a lot better CV construction and flow, and you'll achieve a better surface result.